gathering. So what's our topic here? What we are going to do?
Boolean algebra.
What you are going to do with Boolean algebra?
Case study about Boolean.
So now we are going to have a discussion on case study for the topic Boolean algebra. So in our course, Boolean algebra comes under our course, that is digital system design. Our course is digital system design. So here as a first topic we have discussed about Boolean algebra. So there are several laws, theorems, and that is the root cause for all the simplifications in our DST. Okay. So now let us have a discussion, the complete history and case study of Boolean algebra. Okay, are you all ready for that?
Yes, ma'am.
Who is going to start first? Yeah, you can.
Boolean algebra is introduced by George Boole in 1854. It is a branch of algebra that deals with the variables and the operations. In Boolean algebra, variables takes place only two values, 0 and 1. Operations takes place and or not and manipulate them.
So these and or not gates are said to be as basic gates, right? So it plays a major role in our Boolean algebra. Yes, then?
Yes, ma'am. Next problem statement.
Okay.
So in problem statement, if a company designing a digital security system in a secured area by using the Boolean algebra, the condition might be the employee should have ID card, or he should enter correct PIN, or his biometric was proper, or else these are not correct. If the admin override that, it should be open. We can take that as if the employee has ID card, we can take it is A is equal to 1, and if he has proper ID card, correct ID card, proper ID card PIN, we can take as B is equal to 1. And if if biometric was correct, we can take C is equal to 1. If nothing that if admin override, we can take D is equal to 1. By using this data, we can consider the Boolean expression as F is equal to A dot B dot C plus D.
Okay.
Next, simplification using Boolean algebra. Let's simplify one expression F is equal to A dot B dot C plus D. This expression is simplest sum of products SOP form, and D can alone bypass other conditions.
Next, the Boolean expressions by using logic gates. We give A, B, C, D as an input to the AND gate, and the A, B, C inputs are connected to the AND gate, and D is a direct input, and the outputs are get as a OR gate. The A, B, C as a 4 OR gates, and finally the gates to be opened.
Here we can also discuss about the sum of products and product of sum. That is very important in Boolean, right?
Yes,
Min term and max terms. Right? So sum of product is said to be as min term, and product of sum is said to be as max term. So probably that we are stick with only min terms or max terms. That is SOP. Right? Yes. Please proceed. Continue.
Now we are going to the next step, like real world impact on Boolean algebra. It has a huge things on the technologies, science and everyday's life. And first and foremost in the computers and digital things in this system. Firstly, like in computers, chips and all, we are using the Boolean algebra things, and secondly in search engines and the databases, and thirdly in engineering and control systems. In engineering and control systems, many things like elevators, washing machine, and these all things are based on the logic gates, and it works in the same principle. And in the decision making softwares also, like in programmings, in if else statements, the decisions are making like in the basis of the logic gates. And another thing is data security and networking. And lastly, artificial intelligence and machine learning. It is based on it is the foundation for the artificial intelligence is based on the logic gates and the Boolean algebra, and this is all about the real world impact. And finally, we are concluding this without Boolean algebra, there is no computers, networks, and everything like these things. These all are based on the logic gates and the Boolean algebra things. Thank you.
Yeah, that we have to accept. It is accepted. Finally, without logic gates or without Boolean laws, we cannot go with digital systems, right? Yes, really. I hope now you had a very good idea and clarity about Boolean algebra. Yes?
Yes, ma'am.
Yes. Shall we wind up?
Yes, ma'am.
Thank you all.
Thank you.